Hey, good morning, folks. Happy Tuesday. Hope you're doing well. No, Wednesday. I know what day it is. It's Wednesday, right? All right. Just got my coffee going here. You guys got yours? Let's see if we can pull up, see what's going on today. Good morning, Demovsky. That's right, there's a V in there. Bad with names, I'm sorry. I just have to practice. I'll have to practice. It's Wednesday, yep. Oh, man. No, that's good, though, right? That's good. I thought it was Tuesday, but it's actually Wednesday. That's a bonus. Alrighty. So we got through part 1 of arrays. Talked about how we can use an array to store multiple pieces of data of the same type, which is super cool. So I can store a bunch of numbers, I can store a bunch of strings, I can store a bunch of really anything I want, any type that I want, I can store in an array or an array list. And we looked at some quick differences between arrays and array lists here. So let's fire up Netbeans. And then we also talked about Project 4. Do you have any other questions about Project 4 while we're at it? This is trying to build the big integer or big int class that uses an array or array list. You'd be much better off with array lists to store the individual digits of a really big number so we can add and subtract them from each other. And we talked about a couple different scenarios that can happen because we are going to add and subtract positive or negative values. Right? So if we have some big number here, right? Like 721,983, and we wanted to say like add a negative 3, 4, 5. Right? Well, adding the negative is the same as subtraction, right? So we just subtract. That one's pretty easy, right? Adding, sure, we can just add. Now, what if, though, this one was a negative and we were adding? Right, that's going to make us less negative. So we have to find the bigger number and subtract the smaller number from it, and then your sign stays as the bigger number. Right? Kind of this funny stuff here. But that's all well and good. So how do you figure out which number is bigger? Well, we could figure out which number is bigger. It's not the hardest thing in the world. It's not the easiest thing in the world either, but it's not the hardest. If they have a different number of digits, right? This one has 6 digits, and this one has 3 digits. That's a 3 there, not a squiggly S. Which one of those is bigger? Right, the one with more digits? I know you're all shaking your head nodding, right? The one with more digits is bigger. Okay. So that's a quick way to check. But what if they have the same number of digits? What if this other number was, I don't know, 9, 2, 4? What if they have both the same number of digits? What do I have to check to see which number is bigger? Right, are we checking the leading digit? Right, what if those are the same? What do we need to check? Well, then you check the next one. And then you check the next one until you find one that's bigger. Yeah. And I compared the digits. So if we're doing this minus that, well, this second number is bigger, we have to flip it. Right? We have to do first minus second, and then we're going to be negative. Right? Because we know it's bigger. So a lot of different little scenarios there. A lot of different ways of looking at it here. So just some thoughts for you there. There we go. We got Netbeans here. Awesome. We talked about Chapter 7 arrays. So remember, with a basic Java array, you have to tell it how big it is. So we say, hey, I want to say like an int array, call this numbers. No, that's terrible. Sorry. Numbers, right? It needs to be sized to a fixed amount, and then it cannot be bigger and it cannot be smaller. So we either say equals new, that's terrible as well. This is why I type usually. New, still backwards, and EW, int array of size. And we tell it what size we want. Now size could be hard-coded into our program. Size could be a variable. Either way is okay, right? Either way we want to define size is okay, as long as that's an integer. We can create that size, but then you're fixed. You get that many digits and that many positions. So if we say this is size 6 here, I will get 6 integers, room for 6 integers in memory. And remember, they're all index-based. So we have indexes here. Indexes always start at 0. It's going to be confusing until you've done it over and over and over and over and over. And then you'll wonder why we ever started counting at 1. So we always start counting at 0. So we have indexes 0 through up to size, but not including size. Which makes looping through arrays really nice and easy with a for loop. Let's see. We have our code here. There we go. Okay, so we just wanted to, here we go. More numbers here of size 10, and we added a bunch of numbers. To loop through them, a for loop is really handy. You can say, hey, for index is 0, index is less than length. So arrays have a length property or attribute here. And you want to be less than length, because if you have 6 numbers, your length is 6, but there's no index 6. You have indexes 0 through 5. Now, you'll see a lot of people, and Mr. Gaddis too, like using I here. And then they'll put I in here. I'm not a fan of that. Sure. I mean, okay. Yeah, we saved a couple letters, a couple places. And if that's the only thing we're doing, sure, it's nice and straightforward. But often, we get into trouble where we have other things going on in here, and then that I gets lost really easy. So I would just prefer to be called index. That's just a thing about me. Okay, so I'll call it index. And that's what it is. It's the index in the array here. So that's nice and declarative. Now, array lists here are of a given type, using this greater than, less than, these brackets here, angled brackets. And we tell it what type it is. So it has to be the class version, not the primitive type int or double or float. Right? It has to be the class version here. We create a new array list, and then we have an add method. And add just adds it. It'll just throw it on the end. So array lists are resizable, and they're fantastic. They can get bigger and smaller. We can add things, we can remove things, which is really cool. So they're very flexible. So I will almost always prefer array lists to arrays, just because they're flexible. Another way of initializing an array, if you know the values, you can put them inside of curly braces. Who knew? And Java will figure it out. Okay, so we did some numbers. We added a bunch of numbers here. And then we did some min, max, and average. So we looped through, right, the length of our array, and we found the smallest, we found the biggest, we got the total, and we divided the total by the length to get the average. So that is using the square brace index notation. With an array list, you use get to get the value out of an index. It also has a size property instead of a length, or a size method instead of a length property. That's size with parentheses versus just dot length as an attribute. A little confusing, sorry, but it'll just take a little bit of getting used to, and we'll figure it out. So we can get the values out. You can also use set to set a value if you want to change it. Right, with the array-based notation, we just said, hey, my array at this index, and we assign it a value. We're able to use the assignment operator. This is all well and normal. So unfortunately with array lists, you don't get to assign, we have to use set. So it's a little bit different, okay? not the worst thing in the world to set a bunch of values, right? Where were we setting ours? Oh, we were just adding. We weren't setting. So we had just done add before, and adds to the end. But if you want to change one, right, at a given index, you could set a given index. Okay? And you can do the same min, max, average out of our array list with the get notation and dot size here to get those out. We're just kind of exploring those a little bit. Okay, so it's a new way. So we keep on expanding our toolkit here of new things that we can do, which is fun. It's always nice to have new tools to help us solve problems. So I'm just going to grab our text here, make sure I'm not missing anything important for you folks. And we'll keep on working through our arrays. Okay. Excuse me. So a common thing that happens then with arrays, and you know, it's unfortunate, but it does happen. Say I were to come in here and say more numbers index of 10. Mr. Geddes says that people pronounce it sub. I've never heard that. I've always heard index, but sure, why not? I try and set the 10th index to a value here, but my more numbers only has 10 indexes. So I know because it's size 10. Oh, thank you so much, Fallen. Grab some more coffee here. Stay hydrated, folks. I know because it's size 10, I only have indexes 0 through 9. So this is an invalid index. So what's going to happen when we run this? If it runs. Come on, Netbeans. Wake up. There it goes. Maybe. Aha. 1, and we'll stop. Boom, here. Array index out of bounds exception. Index 10 out of bounds for length 10. It crashes real hard. If you try and get at an invalid index, it fails. Right? It will just crash hard. So we do need to be careful when we're accessing indexes, that we get correct indexes. Or maybe I'll just leave that as a comment. This will cause an exception and crash your program. Bad news bears. Okay, we don't want to crash. Crashing our program is sad. Let's check that with the list of numbers. List of numbers. Get, say, let's just get 10. Let's run that. So if I don't add 11 things, there'll be no index 10. And this flexible, I was just adding as many as I wanted. Let's just try adding something. So add 1, and then like a -1 to stop. And oops, index out of bounds exception. Hey, same error. Index 10 out of bounds for length 1. This little trace here is a little bit bigger. Remember, we look down from the bottom here. So start at the bottom, ignore these XML ones. Our Chapter 7 arrays, line 24, is where the exception happened. Trying to call arrays get, which does a bunch of other stuff. Don't worry about any of those. Okay? So the problem here was with our line 24, reading that this is a stack trace. Okay? So again, this is also bad. Let's be added more than 11, added 11 or more numbers. Numbers, this will also crash. I guess also is not the right, I mean, this crash happened after, but okay. I'm just working backwards in here. That's okay. I think you guys understand, right? Okay, so going through, looping through values is actually so common that the fine folks who write Java gave us a shortcut for it, which is really cool. I'm a big fan of this shortcut because, as you know, all good developers are lazy, and that we want to be efficient, right? We don't want to do more work than we need to. So this is the, usually we call it like an enhanced for loop. This is for read only. This is really important. Read only. Okay? We can't be changing values with this loop. You can change values with a loop when you access stuff by index, because you can change what's at that index. With this enhanced for loop, you can't. Okay? So you say for, and then we say int number colon the collection. Or ours was more numbers, right? More numbers. I'm going to say for every number in, it's, I don't know, it's a colon, but think of it as in numbers. Let's go print number. And why is it not happy with me? Oh, number's already defined. Okay, so int, I don't know, single number, maybe? I feel like we could sing a song about all the single numbers. Turns out I'm tone deaf and have no idea how to match pitches when I'm singing. So I won't sing it for you, but if you have the tune in your head about all the single numbers, maybe you'll have a good day today. It's a catchy tune, right? And I'm sure, you know, I would get the DMCA warning here for infringing upon someone's copyright if I were to sing it, right? Because I'm sure it'd be close enough to pick up on all the algorithms. So anyway, this is the enhanced for loop. So you say what type it is, the variable name for it, in the array. You can also do this with array lists. So it's what, for, and you say type, variable name, colon, as like in, read that as like in or something, I don't know, colon, the collection. Or array / array list for our purposes, array or array list. Array. The word has lost all meaning now. Okay? We can loop through like this. Okay? But just make sure we're not changing values. If you try and change the value of single number here, it doesn't work. What you're actually getting is a copy here, which is interesting. Okay? Now, I had mentioned before that arrays can't be resized, right? Once I set my more numbers to some size, I can't change it. That's not exactly true. I mean, what I can do, just like you could say, hey, we had a number, right? Didn't we have number somewhere? Yeah, number, right? We can like change the value of number. I can say number equals 10, right? Like I can change number. Sure. You can do the same thing with an array. You can change the value of the array, but it doesn't resize it. Here, so like this numbers list here, I could then say numbers equals new int of, I don't know, let's say 50. As soon as you do this, these values get trashed. This creates a new array, trashes the old values. Right? This other location in memory where this stuff was stored is going to get thrown away and garbage collected. So you can make a new array, but it's not resizing the old one. You don't get to just keep those old values around. Okay, so it's not usually what you want to do. So we never loop through numbers. We don't need that. Okay, that'll be okay. We can leave that there. So if we wanted to copy an array, right, say we wanted to just expand this here, we'd have to make a new array, copy them over, right, and then assign it here. So this would just blow it away. What we could do instead is we could say int array, this is a numbers copy, equals new int array of what size? How big do we want to be? Well, let's make this one, I don't know, 25. Okay, again, int array notation. You might also see some people put the square braces over on this side. That's usually considered bad form. It works, but usually we like to see them on the type, just because. It's just a convention. Okay, so Numberscopy makes a new array, and then we can say for int index is 0, index is less than numbers.length, index plus plus, and then we can start copying values. We can say Numberscopy at index is equal, let's assign it numbers at index. Numbers at index. Let's go through and take each one of them and assign them, copy them over into my array. Cool. Now I've copied over these values, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Copied over 10 values, and I have room for 15 more. But now it's called Numberscopy, and that's not really what I wanted here. What I could do instead is I could say numbers then equals Numberscopy. Now here we've done a dangerous thing. Remember, when we say one reference type equals another reference type, when we talk about two strings, they both point to the same string in memory, and it doesn't make a copy. So this assignment operator doesn't make a copy of arrays. It doesn't make copies. It creates, what is our term for a? Just makes it point the same location in memory. There's a term for it, but it's not at the tip of my tongue right now. So what happens, right, when we make this array, we've got some array out here in memory. We make another array out here, and we copy those values down. Right, copy them all down, and we have a lot more space over here. And then I say, hey, your first thing, your numbers here, you don't point here anymore, you point to this thing. But I also have the copy, Numberscopy, pointing here. So I have two variables pointed to the same location in memory, which usually is a bad thing. In this case, we wanted to have a copy, and that's how we make numbers point to a new thing, but keeping all of its old values. So that's okay. Just be careful. And like at this point, we'll probably just get rid of Numberscopy. We won't use it anymore. We'll just stick to numbers, that sort of thing. Okay. Now, what's fun is we can write methods here that accept arrays. So let's come, I don't know, come on down here. Let's make a public void stats that takes an int array for numbers. So if you pass me an array of numbers, I can generate some stats. So let's do all of this stuff we were doing over here. I'm going to cut all that out and throw it all in here. I'm just going to call this numbers. Okay, so I can ask for an array, and I'm going to call it numbers, and I can do this arithmetic anytime I want. So I'll just ask for stats of the more numbers, users' numbers, right? And call my method. Oh, what's the, that's right. Sure, we'll just declare those again. Why not? Uh-oh. Oh, the method has to be static. I'm sorry. Public static void. There we go. Now I can write my method here. Okay? So you can call stats on the array, and we just pass the array. Remember, so arrays are objects, so they are passed by reference. Or, I mean, value, but the value is the memory reference. So I think that distinction's a little silly. So we're not making a copy. So when I pass an array to a method, it has full access to it, and it can change it all at once. What it can't do is reassign it. Right, at the end of this, if I were to say numbers equals new int array of size 1, right? It will change numbers for inside the method. Remember, just like when we passed a string that was a reference type, we could change it and it would be repointed for inside the method. But when we came back to where we called it, user's number, my variable here, still points to where it used to point, because I haven't changed where this one's looking. I haven't changed where this one's pointing. I said, oh, my copy down here, you point to a new location. So we could modify the array, but we can't reassign it to a new one. Okay? So let's put a breakpoint in here, and let's watch for fun. Let's put this in debug mode. See if we can get some numbers out. Okay, let's see. It should be waiting for us to enter some things here. Yep, so we'll enter 1, and then maybe -1. Sure, we didn't need a lot here. Okay, a number game. Let's enter 5 numbers. So throw out some numbers for me. Let's enter 5 numbers into our array, and we'll see if our stats can get generated. Five, 5, 5, 5, 5. Okay, you got it, Dusty. I need a couple more numbers, chat. Help me out here. I've not had enough coffee to think of numbers. Well, that's weird. I grabbed it without this. All right, 4, 9, 8, 5. Okay, good, good. Couple more. Thanks, Cyber. Cyber Pixie 21. Is Tinkerbell a pixie, or is she a fairy? She's a pixie, right? Is there a distinction between pixies and fairies? Curious now. All right, 3 more numbers, chat. Help me out here. $80-20. Okay. Yeah, that reminds me of the 80-20 rule. That's a good rule. 2. Okay. One more. We're getting there. We can come up with 5 integers. We're 11 weeks into our course. 73. Sorry, Fallen, you're just too slow there. All right. So we finally got to our line here. So we've got users' numbers. So I can go to variables here, and I can open up these arrays, which is super cool. So I can see all the values. I just got to drag this up a little bit for you here. Okay, so users numbers. Here we go. It's an int array. Length is 5. Look at that. And I can open it, and I can see the individual values of 0, 1, 2, 3, and 4 by index. I know, Fallen, it's so sad. I didn't use your number. Here, tell you what. I'll just come in here and I'll change it. I'll put the 20 in for you. Does that make you happier, Fallen? In debug mode, you have the power. You can change stuff, which is crazy. But for fun, you can. Okay? So sure, I changed it. So now let's step into our code. It should jump to our stats method. Here we go. So now this array is called numbers. Oh, okay, sure. Numbers. We've got a bunch of numbers. We want to step. We're going to assume the first thing is the biggest, the smallest, and starts off as the total. Oh no, we start a total at 0. That's right. We're just going to keep on looping through. We'll see index go bigger and bigger and bigger. The index is 1, on and on and on. We check for smallest. We check for largest. Nope, we have a new biggest number. We add to the total. Keep on going. Now index is 3. Right, so index 3, that should be 2. That should be a new small number. There we go. We have a new small number. We add to the total. And index 4. We don't have a smallest. We don't have a largest. We just add to the total. Loop is done. Look at that. And we'll print out our min. We'll print out our max. We'll print out our total. Print out our average. And here we go. Let's reassign numbers. Let's say numbers. We don't want you to store those 5 values anymore. Store a new integer array of 1 value. Arrays of size 1 are really pointless, by the way. Just FYI, in case that wasn't clear. Because storing one thing in an array is the same as storing one thing. But you can. Java lets you. It's like, sure. Yeah, numbers, you want to store one thing? Go for it. And you'll notice, though, it does get a value. Right? We get the default value, which for numeric types is 0. So if you haven't given in the value yet, like if we size it and say, hey, I've got 100 values, we're going to get 100 zeros to start. Okay, and then we'll step. We come back now. Now my user's numbers is still here, right? It didn't get changed because user's numbers was still pointed at this location in memory. All we did in our method, right, we said here, users numbers was pointed over here. What we did inside the method said, oh, you know, mine, I was calling it numbers. You point over here now. User's numbers never changed, right? This little numbers variable changed. Okay, that's all that happened. Okay, and again, you can see, so our list of numbers, you can do the same thing. We can expand the array list. Oh, we only have one value. That's kind of boring here, but its size is 1, right? Okay, and we can stop our debug mode. So definitely worth looking through debug mode, but yeah, yep. So you get arrays are passed by reference. We have access to modify the array. So they don't have a copy. So they can change the numbers. So just be aware, right? It'll make some difference later. Okay. How would we want to check to see if two arrays are equal to each other? If more numbers was the same as numbers, right? Could we say, we check here, like, and say if more numbers equals users numbers? Users numbers. Not users numbers. Oh, I have to do that lower down. Sorry. We have to do that after we declare users numbers. Here we go. We can print same array. Else print different array. What do you think this is going to check for us here if I say equals equals? Right, if we put in the same values here, if we put in 1, 2, 4, 8, 16, 32, 64, 128, 256, 512. Is this going to check if their contents are the same? No, you're all shaking your head no. You know better than that. That's not that smart. What this does is checks to see if they are the same memory reference. Remember when we did this one up here, numbers equals Numberscopy? Here, the double equal sign would work because they are the same thing. They point to the same location in memory. Doesn't have anything to do with values here. This does not check the contents. Okay? So what we could do is let's write a method. Let's write a method here. We like methods, right? Find that little double arrow. That is hard to find sometimes, man. So let's see. So public static void. Let's make this a Boolean, right? Let's return a true or false. Are arrays the same? Takes an int array first and an int array second. Why not? Right? You pass me two arrays, I'll tell you whether or not they're the same, true or false. Okay? So the first thing, the easiest thing to check here is we can say if first.length does not equal second.length. We can return false. Boom. They are not the same. If you don't have the same number of digits, or the same number of values, sorry, not digits, if you don't have the same number of values, you can't be the same. Right? You just can't. Okay? If this is not true, we did not return. So again, the else is kind of redundant here, because if you hit a return, your method's done. Right? So you don't really need the else because it's redundant. So we're just going to say, okay, if the lengths are the same, then we can say for int index 0, index is less than first.length or second.length because they're the same, right? We don't care. Index plus plus. And we can check if first at index, so I like this at. Kind of read the square braces like at index of, first index of index, or at index. I like saying at a lot, is not equal to the second at the index, we return false. Boom. If you find a value that doesn't match, they're not the same. And we check for every index from beginning to end. Go check them all. If we've gone through this entire loop and we haven't returned false, so the code we'll get to here, we can return true. If we got here, all the values must be equal to each other, right? So if we got down to here, we didn't return false, then they all matched, right? If this if block never ran, we return. So it's not an else, because that would return the very first digit. But the first time we find a non-match, we return false. If we don't find a non-match at the end of the loop, we can return as true. Okay? Does that make sense? How we can compare our two arrays there? Sorry, I keep leaning farther and farther and farther away. So, oh, there we go. I think I'm due for a new office chair. It's been a long pandemic with this old chair. Maybe could use an upgrade. Ooh, wonder if I could write that off on my taxes. That's a good question. Anyway, sorry. Where was I? Our arrays here. So we can check to see if they're the same. Okay. Mr. Gaddis gets into this idea, and it's a terrible idea, but people do it anyway. I don't know why. They might say, oh, you know, I don't know how many values I'm going to need, so I'm just going to like put 50 out here, and you might not use all of them. That's a bad idea, right? Don't do that thing, the partially filled array that he talks about, because we have array lists. Array lists, we can add as many as we want. I don't need to size it bigger than I need and then only use part of it. I can use exactly as much as I need with an array list. Which, again, take the data structures course behind the scenes. It's not entirely true, but for our purposes, that's true enough, right? Java will take care of it for us. Okay? We like array lists. Yep, that's good. Here's a fun one. Here's a fun one. So let's make an array here. Well, let's make an array list, because array lists are easier, right? We like array lists. We're going to make an array list of type string. We'll call this friends equals new array list of type string. And then we need to get a bunch of friends' names. So we'll say string name equals nothing, right? We'll say while name dot equals ignore case. How about stop? And we really want not. Well, it does not stop. Let's ask the user to enter a name. So we'll enter the name of a friend or stop. And we'll get the name. Name equals keyboard.nextLine. And we'll take the friends and we want to add to it the name. But we really only want to add that if the name is not stop, right? So it's a little bit sad. You have to kind of repeat yourself here, but don't feel too bad about it. Okay? Because we want to make sure we don't add that sentinel value there, right? If they did enter stop to stop, don't add it. Okay? Or maybe we could do a do-while loop, but again, I hate do-while loops because you have to have a semicolon. That's really the entire reason I hate them. Just because of that semicolon. It offends me. For no good reason. But, you know, everyone has to have something, right? Okay, so with an array list of strings, this gets really funny. So what we have here, right, remember we said arrays give you a contiguous block of memory. Well, what is a string? Right? And pretend this was an array or an array list. It doesn't matter. It'll do the same idea here. Remember, a string, we don't actually put the characters here. So if I say, hey, my friend Larry doesn't actually get stored here, right? That's not what happens. Because I don't know how big that is, right? No idea. It could be, I could put my friend's name as like 1,000 characters. I mean, that's probably against several naming rules and things like that, but no one's going to stop me from doing it. Java won't stop me. So it doesn't actually store the string inside the array. What it stores is a memory address like x325b that points to over here where I have stored Larry. And then over here I might get x721a, which points over here. Got a friend named Vlad. Right? And then maybe this one points to, say, x4592. That points over here. Right? And maybe Brandon. Right? So what you get with objects or reference types is your array is just storing memory addresses, which is pretty cool. Right? So what we actually store is where the other thing is in memory. Okay? That's something to keep in mind. When we first create it, remember we get the default here. So until we give it a value, these are null. Reference types. Yeah, XAEAXII, yet Elon's son. I heard they had to change it because California does not allow special characters. You can only use the 26 English letters. Possibly the dash. Possibly the dash. And maybe an apostrophe? I don't know all those specific rules, but it did not like that AE thing. For sure. Because that's a weird character. Right? So if you have reference types, the default here is null until you add something. So if you make an array of size 10, you're going to get 10 nulls until you start adding things. So you do need to be careful to watch out for nulls. Nulls are a little bit weird. Okay? Let's see. Searching through an array, yeah, we could do that. We could try and find a value in an array. That's fun. Why not? Let's write a method. And let's call this public static. And how about Boolean, right? And we'll call this find. If you give me an int array for numbers, and you give me an int value, I'm going to see if I can find that value. Or maybe contains is maybe a better word for it. Contains. I like that. So is this value contained in this list here? Well, we have to loop through. So let's use that enhanced for loop. We'll say for int number in numbers, if the number equals the value, we return true. We found it. We contained that value. If we've looped through everything, we return false, and we haven't found it. Right? Loop through every item. No, return true, not string buffer. That was weird. Loop through every number in numbers. This is that little enhanced for loop. If the number matches, return a true. If we've looked at everything and we haven't returned a true, return false. We don't have it. It's going to look at every single item in the list to see if we find a match. Sure, we could do that. Okay? And the next topic is two-dimensional arrays, and that's going to take a little bit longer to talk about. So why don't we wait? We take a break a couple minutes early, and then when we come back, we can talk about two-dimensional arrays and finish out the chapter. Because two-dimensional arrays are fantastic, but it's going to take a little bit of working with it. Okay? You all right with that so far? How you folks feeling about arrays? You're like, you love them, you think they're amazing. Wonder why we didn't start with these earlier. I don't know. Okay, hopefully it's making some sense. You know, it's going to take practice. Definitely going to take practice. Okay, using this index notation, right, at a given index, or with our array list, right, get, right, get and size, depending on which one we're going to use. Thanks, Dusty. Glad it seems good. All right, so why don't we take a couple minutes? We'll take a little break. We'll fire up two-dimensional arrays when we get back. Let's see what we get here. All right, awesome. Hey, hey, everybody. Welcome back. I think got a minute here. Oh, I forgot to turn the volume up. Hopefully it wasn't too bad over break there. Hey, not prof. Thanks for dropping on by. We are having fun with collections of numbers, or really anything, but we're using numbers because they're easy for our example here. You're doing arrays and array lists in Java. Welcome on in. What were you talking about? Oh, definitely. It's always coffee time around here. What were you folks talking about today? Let's see, can I do this? Yeah, here we go. This shout out command. I can do this. Look at that. Thank you, Nightbot. You're so kind. Go learn some math, folks. Hydration. Thank you so much, Fallen. I will drink more coffee. No complaints there. Just filled up my cup. Made a fresh pot. Well, we made the fresh pot earlier, so I haven't finished off the first pot yet, but we're getting close. Exponential growth and decay. Ooh. Those are fun. I don't know what a Jacobian matrix is, though. That sounds cool. Matrices are neat. We're actually going to talk about something that's, I don't know if you want to call it a matrix, but we're going to talk about two-dimensional arrays here, which maybe you might call that a matrix. Maybe? All right. So, remember, what an array lets you do is store a bunch of values of a given type. Matrix of partial derivatives. Oh, I totally know what that is then. Yeah. So the type that I want to store here then, right, what I can do, let's draw a picture of it first. Let's just here, I'll scroll down a little bit here. So what I can do is I can have a bunch of values here. So I want to store another array. 1, 2, 3, 4, 5, 6, and 7, 8, 9. Okay, so each thing here is another int array. Int array. Int array. Right? And that's okay, because the thing that my array is storing is of the same type. They're all int arrays. So to declare that, you say int array array, and we'll call this a two-dimensional array, equals a new int array of, well, how, and usually you think of it as rows and columns. And this makes life a whole lot easier for you. Right? Because instead of just being one long list, what you really get then is, let's just kind of imagine it here as 1, 2, 3, 4, 5, 6, and 7, 8, 9. Okay, imagine that, and that is all an array here. So this is index 0, this is index 1, this is index 2 of the row, and this is index 0, 1, 2, and 3. Those are like the columns here. Right? So the first thing in my array is this array. The first item inside of that is 0. So at 0, 0 is the first value here. At 2, 2 is the value over here. Right? Row 2, column 2. So usually we think of these as rows and columns here. So, and we could even use the array initializer syntax here, right, which is probably a little easier for us. So instead of that, we might say another array initializer, 1, 2, 3, comma. Remember, so a single set of curly braces is an array initializer, and we need an array of arrays. So I'm going to say array of, here's an array, and here's the next array, 4, 5, 6. Nope, I need curly braces, please, not square braces. Curly, thank you. And 7, 8, 9. And then that ends the other array and a semicolon. Give that a little format. And you can even bump these down here. Remember, Java doesn't care about the white space. So if you want to bump this down because it makes more sense to you to look at it that way, I'm all for it. I like that. Right, so here's the outer array. Here's the inner arrays. 4, 5, 6, 7, 8, 9. So what we would do to get all the values out, we would say for int indexes, and really I like this as row index, is probably better. 0. Row index is less than my two-dimensional array dot length. Row index plus plus. Plus plus. And then what we do, so for every row, we need to loop again to get every item out. So we're going to say for int column index is 0. Column index is less than, now here's where it gets tricky, because these are not guaranteed to be squares, right? If I wanted here, I could add a bunch of other values here. That's called a ragged array, where they're not the same size. So you never want to go off of the row size. You need to go, or I'm sorry, you never want to go off the number of rows. You want to go off the number of columns. Well, to get that, that's two-dimensional arrays at index of row index. That itself is an array, so that has a length property. And then column index plus plus. So this gets a little bit long here, but that's okay, right? We're okay with it being a little bit long. We will survive because this is much more readable, I will argue, than what other people do. Terrible things. Okay? So then we can say, we'll say row, we'll add the row index, and plus column, plus the column index, plus, I don't know, and then the actual value there. So let's, man, this is getting long. I'm feeling bad. Row and column, and then plus the actual value. So to get the value out, then, let me put the plus over here. I'm going to add, we go to the two-dimensional array. We say, well, which item inside of it? Well, we need the row index, right? Which item inside each row, right? Here's one row, here's one row, here's one row. Well, that's the column index. So it's row index at column index. Here, will get me the value stored there, right? So this is 0, 0, this is 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2, right? Row, column, row, column, row, column, row, column, row, column, row, column, right? So we could do this, and we could get the values out of our two-dimensional array. It's super cool. Two-dimensional arrays are amazing. You can do lots of cool stuff with them. All right, so if we run that, we should get our numbers right out. And no one's going to know that it's a two-dimensional array because we're just printing out what values 1 through 9. Oh, we got to do enter our other values here. That's okay. We'll get there. 1, -1 will stop. One number, let's enter 1. Sure. Name of our friend, we'll just say stop. Okay, so here we go. Here we go. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Row 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2. Right? If we wanted to recreate this just for fun, right? Let's do this again here. Let's try, I'm not even going to copy this. Let's do this with the enhanced for loop, right? But the enhanced for loop says, give me the type. Well, the type is int array row in two-dimensional array. Right? That's going to give me each row. Then I can say for int value in row here, we can do something. Right? So the enhanced for loop looks a little bit different here because the first type is an array, because what we are an array of arrays. Okay, so each row is an array, but then each row then just has individual values here. Sure, we could do that. And let's print out here, but let's just print and not print line the value plus a space. So remember, if I just print, it's not going to go down a line. That's okay. We're just going to space separate every value in the row after we've done this loop here. Remember, you can put loops inside of loops. We've done this. Then what we can do is we can just print just an empty print line to go down a line. And then we'll go to the next row. Print all the values, space separated, go down a line. Print all the values, space separated, go down a line. Go to the next row, on and on and on. So we can kind of recreate that view or the look of it with 2 dimensions this way. And again, you don't have to use the enhanced for loop. You could still use this column index, row index stuff. Perfectly fine, right? But again, this is a little bit less verbose, right? Depending on what we want to do. Stop, enter one number, enter a number, stop. Okay, right? So we see we get this two-dimensional view back out here. And it just totally depends on how you want to process it, what you want to do with it. Up to you. You know, two-dimensional arrays are amazing. We can do lots of cool stuff with them. Yeah, that's all good. Sure. Array lists we've done. Yep, we did array lists. We moved. Sure. Okay. All right, that's looking pretty good. So the other thing we can do with arrays now. So And this gets a little bit funny, but it's okay. You can do, so remember, so far this is all the same type. This is integers and integers. Well, what if I want to have like a list of students and their grades? Right? So maybe I want to make an array list of type string, call student names equals new array list of type. Now, Java is smart enough, if you put the type here, it'll let you skip putting it over here. So it knows that, oh, you want string. So when you try and autocomplete, remember it won't put the type here. Don't worry about that here. It knows that it's the type of this here. And then I'll have an array list of, oops, caps lock got put on. Array list of type integer. Maybe this will be double here, actually, right? Capital D double, right? Can't use those primitive types. This is student scores. New array list of type double. Boom. Cool. And then maybe we'll loop. Oops, too many parentheses. Okay. And here, you know what? Maybe we could even ask them how many students are in your class. We can have an int number of students equals integer.parseInt of keyboard.nextLine. Next line, please. Thank you. All right, and then we can say for int student number 0, student number is less than number of students, student number plus plus. Right? Sure. We're going to loop this many times. And this just helps us avoid a sentinel value. Just because, right? If they know how many students are in their class, which they probably know, it's fine. What we can do here is we can say enter the student name. And we're just going to add that right to student names. So student names.add keyboard.nextLine. Right? Just grab that next line. Oh, sorry. Forgot to put my phone on quiet here. Okay. And then we can ask for enter the student score. Okay, so we'll get a name and a score, name and a score, name and a score. Or maybe we want to save that off as name. Sure, why not? We can do that. String name is keyboard next line. I like this. This is better. Keyboard next line, and then we'll just add the name. And then we can say enter the score 4, and we can put in here name. That's a little cleaner here, right? Well, we already have a string name. Well, student name. How about that? Student name, and we'll ask, hey, enter the score for so-and-so. And then I like having colons at the end of prompts just because I think it looks a little prettier. I don't know why. That's okay. Okay, and then we will take my student scores, and we're going to add double.parseDouble, oops, capital D double.parseDouble of keyboard.nextLine. Right, you enter a value, turn it into a double, see if we can add it. Now what we have here, right, if we kind of imagine what this might look like, we're going to have what's called parallel arrays. Okay, we can have, here's a name and here's a score. 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 We can do that, right? We can enter some names and scores. Now, I'm going to argue that this is a lot of work, and then we have to keep them straight, and we could do better. Do you know how we could do better? We can add a class instead, right? Because we can make our own classes now. Let's make a class called student. Remember we talked about classes? So classes have attributes, they have the ways of interacting with them. So things that we know about student. We know students have names, and we know students have scores. So private string name, name, and a private double score. Right, we'll write a constructor here. Right, the name of the method matches the name of the class, no return type, that's a constructor. I want you to give me the string name and the double for score when you create an instance of student. Right, I'm going to take this name and set it to name. I'm going to take this score, set it to the score you gave me. So you give me name and score, I'll set them as my private values here. Then I need ways to get at those values. So I need to have public get methods. Right, so I'm going to have a public string get name, which returns name. I'm going to have a public double get score, which returns score. That's it. Here's a class. It has no verbs at all. Right? The only things we do are we get values and we set values. And we didn't even give public set methods. We say, hey, once you create them, they're fixed. Sure. But then what we can do here, instead of doing these parallel arrays, which is really obnoxious, we could say, hey, I want an array list of type student. We'll call this students equals a new array list of type student. Too many code races. Right? And then we could do the same prompt over and over and over again here. And then instead of having to do both of those, right, we get the name, we need the score, enter the score for the student name, and then we'll have a double for score equals double, parse double, whatever they typed in. Then I can make a new student. So I can say student equals a new student, and I can give it the student name and the score. Then I can take my students here, and I can add the new student. So this is much preferred, right? Using an array of a class type is much better than parallel arrays, right? So these are parallel arrays. Right? We have two arrays, so we can store two different types. Well, if those types are related, just make a class for it. Right? Classes will be much easier for you here. And we can just store all the information in the class here. Okay? All right, awesome. So we've got that. All right, I think we're doing good. We are doing good on arrays and array lists. Questions, thoughts, concerns? One other cool thing you might have noticed here. Remember main up here has this string args that we've never, ever done anything with, ever? Right? We're actually passing an array of strings when we start our Java program. So you can use this, it's not, the stuff we're doing is not as common, but you can do cool things with it. Let's see, I think it's under project properties. I've not actually done this in a while. Let's see, under run. Yep, here we go. So under run, there's this list of arguments here. So we'll say hi there as some arguments. And I'm going to put a breakpoint in. When I run into debug mode, we're going to take a look at args and see if we can see some values. It's working on it. Here we go. Args now has two arguments. We have hi and there. We're able to pass values to the program. So, I mean, this is just in debug mode, right? Running it here. But what we could do behind the scenes, right? Because, we love our computer programs and we love them to be able to do things. I'm going to go find this file here. Come on. Let's see. Okay. Let's open this up here. I'm going to find that path. Give me a second. I never know what folders I'm going to show on my computer, so I try and move that off. Okay. So I'll paste in the path over here. Sure. Remember, when we build our program, we generate these class files right here, .class. That's our Java bytecode that's going to run. Right? So what we can do, let's fire up command line prompt here, because this is super fun, running stuff from the command line. Again, this is like we would be able to automate stuff like this here. So we're going to change directory to that path. And you can learn how to use the command prompt all sorts of other places here. But, oh, come on. Why is it so slow? Should not be that slow. Maybe I didn't change it right. I thought I fixed that. Come on. we'll edit this real quick here too. We'll say if args.length does not equal 0. Oh, here, you know what? We can even do it this way. We'll just do it in the enhanced for loop. We'll say for string arg in args, capital S string, please. We'll print out found in arg plus whatever that argument was. Okay. So we added our hi there. We should get hi there real quick. Let's see. Right, because we told Netbeans we wanted to add some arguments. Did this ever load? Okay, there we go. We're getting there. Right, we found hi in there. Cool. Well, let me stop that. Let's see if we can do a similar thing from here. So let's see where we are. Okay, so I just had to find this right directory. So here's chapter7arrays.class. So I should be able to go to my C Java stuff, no, OpenDev, JDK something or other, bin Java, oops, Java. There, that's the Java executable. Right, we should be able to point the Java executable at our class file here. At chapter 7 arrays. And maybe, does this work? We'll see. Oh, couldn't find or load main class, chapter 7 arrays. Did I spell it wrong? Chapter 7 arrays? You know, I think I had this problem last time. Shoot, why? It's supposed to work. What did I do wrong here? Chapter 7 arrays. Load main class. Well, it should run our file. Why is it not? It's okay. It's not all that interesting, but it should have worked. Let's see. Should I go and build? Generated sources? No? Empty. That's funny. Why is it empty? It doesn't like it. That's sad. Oh, wrong name. Chapter 7 arrays? Do they call it chapter 7 arrays? Now I'm upset. It should just work. We have to give it this. Chapter 7 dot arrays dot. Oh, nope, still not working there. Okay, I'll give up. I can figure it out another time. You don't have to sit around while I do this. That was super exciting. But it's supposed to work, and you should be able to pass them at the command prompt here. And the idea here is we can have a computer program that says, hey, every day or whatever we want to do, every hour, run a process that runs our Java program. Tell Java to run our class, and then we can give it command line arguments. And those command line arguments can be based on anything we want it to be, whether or not it's the name of a file it should process, or whether or not it's like the date and time of something. So we can use information this way, and it doesn't have to be entered from the person running it at the command prompt. They don't have to type in responses. They could give it as arguments to the program. But for some reason I broke it. I don't remember why. Chapter 7 arrays. Let me try one more. No, you don't add dot class. No, you don't need that. I don't know what I did wrong. I'll figure it out. All right, but eventually you could get those string arguments if we did it the right way, but we didn't, so fail. Sorry about that. Yeah, Java command. Huh. That is weird. I don't know why it didn't work. That's all right. I'll look at that later. RM-R Windows. Delete Windows. Oops. Yeah. Can we just go back, go back, go back, go back? Source. Chapter 7. Arrays. OpenDev. JDK. Bin. Java C. So Java C is the Java compiler. To tell it about students. Okay, so we have to compile student first, I think. Oops. Let's try student. Let's do this the hard way. There we go. Okay, so we compiled student. Now maybe we can compile array. It's right there. Right there. Friend. We can compile them both at once. I never do this by hand because it's obnoxious. Nope. Java C help. Nope, nope, nope. Java C -- help. There we go. This is why we have tools. This is just obnoxious. At file name. From file, we don't want that. Source files. Yeah. Do we just comma separate our source files? Is that what we have to do? We should never do this by hand. This is ridiculous. Java C. Maybe I comma separate them. Oh, it's student.class. Nope, I need the .java. Maybe that was it. Yeah, okay. Yeah, if you don't point it at a class file. Look at that! We compiled our code by hand. Now we can tell it Java arrays. Does this work? Oh, come on. Still failed. All right, never mind. I thought we were getting closer. Anyway, arrays, 2D arrays, lots of fun ways of storing multiple values. This is going to bother me now until I figure it out. Don't forget, project 4 is coming up before you know it. This one will be due, right? And this is going to take quite a bit of effort to puzzle through all those possible options on how we get these long integers working. Okay? Remember, you have to figure out what order we're doing things in. Right? If we're subtracting or adding positive or negative numbers, find out which one is bigger. Where did it go? Oh, did I clear it? I must have cleared it. That's all right. We can clear that one. Right, so when you have your list of numbers, right, so I get a bunch of digits here, right, you got to be careful. Make sure we're going to check these in the right way. So adding a big int to another big int, subtracting a big int from another big int, adding a negative big int to a big int, taking a negative big int, adding a value, taking a negative, and subtracting. Right, if we have a negative and we subtract another value here, right, like subtracting from a negative just makes it more negative. So really, we just add them together, and then the whole thing becomes negative. There's like a lot of this, just these little pieces to talk through. So go to study group. Let's see, I think I'm zoomed in funny. There we go. Ooh, 100%. So study group. Today, 12 p.m. to 1 p.m. Plus you get bonus points on the quiz. I haven't added them yet. I've got that category. I'm going to add them at the end. So a point for every time you go, or once a week, you can earn a point. Bonus points on the quiz. Go to study group. Talk about it. Right? Here's you. Here's your little thought bubble. Talking about it. Not code, right? You're not doing code, but we're talking. Right, here's your friend, or your new friend. They're also talking about ideas. How do we solve this problem? Okay? That means the quality of your work is going to go up. Spending time designing your solution, thinking through how do we do all these steps, right? What's involved? Without sharing code, just talking, right? These are some ideas here. This is how I might go about it. This is how I find out which number is bigger. This is how I find out if I need to add or subtract. This is how I might, if I'm really going to subtract the negative, I need to do this thing. You know, lots of ideas. Okay? Then you can meet a friend, right? And once you guys are friends, you can work on the final project together in pairs. Because if you have someone else to work with, you know, the quality of your work is going to go up again. Your score is going to go up. I'm sure there's some studies that prove that. I don't have any to reference right now, but I'm pretty confident there. So study group today at noon, chat about the project, right? And that is coming up due, when's the due date? April 5th. Less than 2 weeks now, right? Where's our calendar? A week from Monday. So you have 1 weekend and 1 more week to work on it. The rest of this week, all of next week, do Monday morning at 10 a.m. I'm going to go over the solution to it. Okay? At that point, I can't take it. So get together, work with your friends, right? Puzzle out some of these steps, that idea, that pseudocode, like this is what the process you need to follow, and we can go from there. All right, folks, that's all I've got today. Let me make sure my code there is out on GitHub, and we can go from there. Okay, and we'll see who else is on Twitch we could go pester. Gotta be someone else around interesting. Go do some fun stuff. Let's see, so 1500. Go. More arrays and array lists. Okay, I'll commit and push. All right. We can go hang out and learn some more math. A boring math professor. Looks like he's online. We can go check out that. Math is always fun. Pseudocode. All right, folks. Let's head over that way. And we'll have some fun. Learn some math. Tell him you guys want the Shungate. He's got all sorts of fun little channel rewards. And we'll go from there. I've got office hours today, 1 to 3. Come and chat if you have questions. If not, take care. I'll see you next week.